Here's example 6 on sketching rational functions. First thing, factor if you can. The numerator will remain the same, x minus 2. The denominator I can factor. There's a common factor of x. So I can factor x times x plus 1. Okay, let's go to our first step. First step is find the y-intercept. And you find that by evaluating the function when x is equal to 0. So you have 0 minus 2, and we take the original function to do that. And then you have 0 plus 0, 0 squared plus 0. That gives you negative 2 over 0. That means it's undefined. That means no y-intercept. Second step, find the zeros. The zeros are nothing more than x-intercepts. We're going to look for the x-intercepts, and to do that I'm going to take the numerator, x minus 2, and I'm going to equal it to 0 and solve for x. X is equal to 2. There is your x-intercept, or your 0. Third step, vertical asymptotes. To do that, to find that, I'm going to take the denominator, the factored form of the denominator, and I'm going to equal to 0. We use the zero product property, meaning that if x times this is equal to 0, then x must be 0, or x plus 1 is 0, or both, and I solve here for x, negative 1. So I have two vertical asymptotes, x equals 0 and x equals negative 1. And step number 4, horizontal asymptote. We look at the degree of the polynomial in the numerator and the degree of the polynomial in the denominator. The degree in the numerator is 1. The degree in the denominator is 2. That means the degree in the numerator is greater, we call that p, is greater than the degree in the denominator. Therefore, the horizontal asymptote is y equal 0. Okay, and as step number 5, we will draw a number line. Here's the number line, and on this number line I'm going to plot only this information, the zeros and the vertical asymptotes. Okay, that's it. So let's see, I have a 0 at 2. Let's say 2 is about here. This is 2. I have a vertical asymptote at x equal to 0. That means there's a wall here at x equal to 0, crooked wall, and I have another wall at negative 1. Let's say over here there's another wall, negative 1. Okay, so these two walls, and let me fix that 0. These two walls and this 0 have divided my number line into 1, 2, 3, 4 regions. Okay, so let's look at each region individually. From negative infinity all the way to negative 1, from negative 1 to 0, from 0 to 2, and from 2 to infinity. Okay, so let's test in the different intervals. I'm going to choose a number that's less than negative 1. I'm going to choose negative 2. I'm going to plug it in here. Negative 2 minus 2, that'll give me a negative result. This x outside the parentheses will give me a negative 2. So this would be a negative number. And negative 2 plus 1 will also give me a negative number. Negative times negative is positive. And negative divided by positive, that's negative. So I will be below the x-axis in this region. Now I'm going to go in between 0 and negative 1. I'm going to choose negative 0.5. If I plug in negative 0.5 here, this value will be negative. Negative 0.5 here, that will be negative. Negative 0.5 here, that will be positive. So negative times positive is negative, and negative divided by negative, that will be positive. So this is positive in between this region. That means I'm above. Then let's choose a value between 0 and 2. I'm going to choose 1. 1 minus 2, that will be negative. 1 outside the parentheses, that's positive 1. And 1 plus 1, that will also be a positive value. So positive times positive, positive. Negative over positive, negative. So I will be below in this region. Below. And then from 2 to infinity, I'm going to choose 3. 3 minus 2, that will be a positive result. 3 outside the parentheses, that would be positive. And 3 plus 1, that will also be a positive value. So this will be above. And there you have all that information. Now I'm going to go to my graph and start at number 1. We said there's no y-intercept. Number 2, I'm going to plot my 0. My 0 is right here at x equal to 2. Number 3 is plotting the vertical asymptotes. Vertical asymptote x equal to 0, that means that is your y-axis. That's your wall, one of your walls. The other wall is at -1, so right here, very close to each other, these walls. And after I do this wall, I have to trace my horizontal asymptote, which is y equal to 0, and that would be your x-axis. There it is. I have everything on my graph. Now I'm going to look at the sign analysis. We said we were going to be below the x-axis between -infinity and -1. In the first region, I'm below the x-axis. Here I have this wall, the horizontal wall and the vertical wall. So we know that the function is coming from below the x-axis, very close to the wall, and it starts separating from the wall and hits and splashes the other wall, getting very close to it but never touching it. For the second region, I'm above the x-axis, and this second region is in between the two walls. And that would be in this region here, in between the two walls. And it's above the x-axis, so that means I'm going to splash upwards in both directions. So I'll splash upwards against this wall and splash upwards against this wall. So it's sort of like a parabola. And for my third region, I'm below the x-axis. That's between 0 and 2. So in between here and here, I'm underneath the x-axis. There's a wall here, right? And remember that 2 is a 0. That means I'm going to cross this 0. So that means I'm coming from close to the wall, separate from the wall, cross right here at the 0. And after I cross this 2, from my sign analysis, I'm going to be above the x-axis, but remember there's a wall here, so I'm going to go above but not too far up, and I will be approaching this wall like that. And there you have this graph. Let's go ahead and do this graph in WZ Grapher and see what it looks like. Here's the graph with WZ Grapher. Notice how the horizontal asymptote is the x-axis. And the graph will approach the horizontal asymptote. It will pull away from it and then approach the other vertical asymptote, which was -1. Also notice that in between -1 and 0, I have this parabola-like deflection of the graph where it splashes up both walls. And on this area here where the graph comes from below the x-axis, it will reach the 0 at x equal 2, cross the x-axis towards the positive side of y, or the above x-axis region, and continue to be very close to this horizontal asymptote. I'm going to zoom this in so you can see that it actually crosses the x-axis at x equal 2. So I'm going to try and zoom this in a bit so that you can see there. right there. That's nice. You see here at x equal 2, it crosses the 0 and it goes over above the x-axis, but will continue to be very close to the horizontal asymptote. See how close it gets, but it never touches. So there you go. Very similar to our sketch, which is right here in my other. Let me close this. There it is. Okay, so I hope this helps you understand how to sketch graphs, and this is the last example. I'll see you in class.